So I'm gonna put you on the spot a bit for IBM with IBM storage. What do you on the storage array side? How do you see that the storage array can contribute to reducing data movement and network congestion? You touched a little bit earlier, but any other thoughts there?
So certainly in inside the storage array, by having compression and such, it helps us to alleviate congestion in the PCI Express buses that are connecting the servers to the SSDs. A, uh, a, to take that a bit further and to look at perhaps AI done for in servers and stuff. How could the storage system help to reduce that kind of bandwidth? I think it gets back to having these filtering engines. Today, to do AI, you've got to bring all the data from the storage system. And that's true whether it's an external storage array like ours or a hyperconverged system that would have a bunch of SSDs in various servers. You've got to bring all the data into the server that's doing the model, the training, and that might be hundreds of petabytes of data that you want to train on. Right? You can imagine a large company with all of their data and they're looking for patterns and looking for customers who bought a specific thing, JB. So now they have to bring all the data in. They have to look for specific records, and that means they're going to have memory bandwidth issues because all of that data has to go into memory and then come out of memory, go into the CPU, and most of the time there's going to be at the end of the line a branch statement that says, "Is this so and so?" And the answer most of the time will be no, false.
Yep.
And so all of that data, which was false, not used, was brought across the network, brought through memory, slowed down the CPU when it didn't need to. So if instead, if and you could do this in a number of places. You could do it in the SSD, like you and I do. You could do it in the external storage controller. You could do it in the fiber channel adapter or the Ethernet adapter with a smart NIC, right?
Mhm.
And each of those would have advantages, and each one could deploy different um, uh, CPUs, different cores that are doing filtering and looking at the data and then sending the data that makes the most sense up to the CPU for further analysis. That is one big way of reducing how much traffic is going across the network.
Yeah, and depending on where you're doing that, it may not have to run at full line rate,
Right.
to be effective, or depending on how many drives you're looking at in the
Right.
array. But yeah, we look at in terms of the CSDs on the compute side. One of the ways that we help contribute to reducing the network traffic is by compressing the data and allowing you to store two, three, four times as much data locally. You've effectively double, triple, quadrupled your local cache of fast
Yeah.
data. So those
Yeah.
petabytes of data that you talked about having to potentially move over for the training, well, instead of moving them in, say, 40 terabyte chunks, you can move them in 80 or 160 terabyte chunks and iterate a few times before you had to thrash your large cache again.
Right. Right. Very good point. And it's similar in the storage unit as well. We find that by having the compression inside the SSD, it um, it and putting the hot data, if you will, on SLC. All right, so we take our SSD and we have there's SLC and some of the blocks we put in SLC, some in QLC. If I compress the data, I essentially have more SLC than I would have, right,
Right.
with compressed data. And so it's a
Yep.
similar kind of caching effect that you talked about, only inside the storage device.
Cool. Hey, so we've hit on ransomware and security, and we've hit on compression. So how, and those two things can be, or data security and compression can be at odds with each other, where if you are encrypting the data before you send it to the device,
Yeah,
or before you send it across the network to the storage array, um, that can really minimize the potential value of the compression. So how do you see that overcoming that as we move forward?
it's a tough problem, JB, because probably accelerated by the pandemic, but not just the pandemic, other geopolitical things. There's there is a lot of ransomware activity going on, and as a result, there's a lot of governmental compliance, governmental legislation happening, and especially in areas of finance and healthcare and government, there are requirements that the data be encrypted, um, you know, the entire journey, and as you say, if you encrypt the data, you will have no compressibility. In fact, if you can compress it, there's something wrong with your encryption. So, uh, a lot has been looked at for this to solve this. You're probably aware of some technology that came out a couple of years ago where it could be encrypted um, at the server, and then you could have keys that share, right? And there are standards around that, and then you can de-encrypt it at the storage. I think the industry is going to have to look at this long and hard and develop some technology that can allow data to be sent somehow encrypted, but still get some compression out of it. And I think we're still the industry is still wrestling with that, and I think hopefully something will come, and we'll figure out that. But otherwise, you're going to see a continual decrease in the compressibility, I think.
Yeah, yeah, it's all of that. How do you share the keys? How do you bring the computational storage device into the fold of the circle of trust, or the
Exactly.
and then there's also been some of the efforts around confidential computing to be able to do some kind of inferencing on the encrypted data. So
Yep.
those may be areas to watch. I know we do have in various standards bodies lots of work now on how do we manage the security around computational storage functions or
Right.
the tasks that we put down into the computational storage devices.
Indeed.
Um, okay, and actually, on that, we already mentioned a couple of things where the computational storage devices may be able to contribute to identifying or detecting that there is a threat or an intrusion
Yep.
that happened.
Yep.
Um, all right. Well, you've thrown out AI a couple of times already, but with NVIDIA dominating the news lately, there's all tons and tons of press about the generative AI and inferencing, everything in general, but very little has been written, or I haven't really seen anything that was directly about how does this interplay with storage, um, and so how in thoughts on how CS contributes to or is complemented by this exploding generative AI market.
Yeah. Well, I think uh, tying it in with some comments you and I made earlier, the the GPUs and for that matter CPUs working together can process huge amounts of data and train a model to do all kinds of things, right? And we're seeing that, and that's a generative AI. But it gets back again to all that data that is being trained has to be stored somewhere, right? And so, in order for you to train a model, you need to be able to look at terabytes, if not petabytes, if not exabytes of data to train. If you're going to train an AI model to recognize a dog, all right, you've got to show that model hundreds, if not thousands, of pictures of dogs so that it can start to recognize. And lots of research is going in to reduce that, but still, you've got a lot of data that needs to be used for that. And so storage comes into play. So, very simply, if the data can be compressed, JB, then it's easier to store it for that training to happen. But it
Yep.
also gets back to what we said earlier. You're not going, you might have exabytes of data, and in those exabytes of data are your pictures of dogs, all right? But you don't necessarily want to run everything you have in order to find the dog pictures. You might again need filtering, searching. And yes, file systems can do that if the person has organized the data very well. But again, it gets back to if you can use filtering, offload the filtering so that you can send the data which is the makes the most sense for training the model, then you can more effectively use those GPUs and CPUs.
Yeah, I think of that as how do we increase the payload of real of relative relevant data to the GPU?
Right.
Because those GPUs, we talk about this as the distributed compute, and and from what I've seen, it's not so much that the GPUs can't churn through the data. They can. There's plenty of processing capability there, but they're wasting a lot of, or they get effectively choked because there's only 64 gigabytes of bandwidth of across the by 16 PCIe 5 bus to shovel in there, and if 90% of the data is just gravel and only 10% of it's the gold nuggets of what they want, you just wasted 90% of your that bandwidth and a whole bunch of that expensive GPU's effective capacity.
That's right. When your SSDs and your storage devices probably have CPU utilizations that are hardly using anything at the time that you're doing that. And so, by doing the distributed nature, making better use of those resources that are probably not being used as much, you now have
Mm-hmm.
a more effective overall system.
Yeah. So turning a little bit from the AI, but still a little somewhat connected. What about the edge? How do you see? And I know edge can mean a lot of different things.
Yeah.
Um, how do you see the computational storage playing out at the edge?
Yeah, and I guess it depends on what your definition of edge is. Again, a lot of times I think it's viewed as out in the manufacturing facility, right? It's out in where the the routers are for the networks for the telephone systems and such. And I think much of what we've talked about has relevance there. Certainly compression, all right. Certainly ransomware detection, ransomware uh, recovery assists, because those are the edge is also under attack. Um, I I think in the edge you even have more, I would say, focus on trying um, to reduce footprint. A
Hmm.
lot of times they're space constrained, JB, and if you can again use all parts of the infrastructure more effectively, perhaps you can optimize and save space in the edge, right? That's one way of looking at it. Compression is part of that, but also offloading again off the CPUs all the work things that can be done in the storage controllers more effectively, and therefore helping you perhaps to reduce. If you're doing compression up in the up in the compute servers, you probably have more of them to do all of that. If you move that into the storage device, like we've said, you can have more efficiency and maybe reduce how many servers. I think that becomes very critical in the edge. What do you think?
Yeah, I see, kind of the further you go from the core data center, when you go to the near edge, or if it's just, a server closet or something, versus the far edge, you mentioned in the factories, all the way out to the IoT. Like the further you go from that core data center, the tighter the constraints on power, on thermals, on space, on cost. All of these things get tighter and tighter and tighter and more stringent. And so it behooves the solution to be more and more and more efficient.
Yeah,
And by that, saying, hey, maybe I should I'll stick with the compression. I'm going to do compression in a hardware engine in the drive as opposed to allocating some portion of my CPU. And that allows me to run my CPU at a lower power and have a lower power system because maybe I'm in a closet and I don't have great thermals, or I'm out on the corner in one of those you mentioned
yeah.
telematics areas.
I'll give you an example. We have a storage system called the Flash System 5200. It's a 1U dual controller system. All right, with 8 core processors in each of the controllers. Well, the reason we're able to do 1U, and by the way, the Edge loves it, 1U for up to 378 terabytes of storage. Is phenomenal. And by the way, that's without compression, right? So you could have, if you get 2-to-1 compression, you could have 750 terabytes in 1U. And that's where it really makes a difference, is out there in the edge where space constrained. And you really have a hard time doing that if you were going to do compression in software. You would need more powerful processors. And I'm not in any way knocking those who do it in software. It's just takes space to have those engines do that. And so we can fit into 1U by having and a lot of storage by having the compression distributed across all the SSDs. That's an example of what you're saying, JB, being able to fit into smaller footprints.
Yep. Yeah. Exactly. Um, so I know we've gone long here. What and you've already mentioned, hey, we're still early in this. We've been talking about computational storage for a while. You've deployed it. We've deployed it. There's a couple other solutions out there. Um, when do you see the hockey stick, or when does computational storage become ubiquitous?
Yeah.
I know it's
I,
a future question, but
yeah, that's a future
crystal
question,
ball.
and and for something to become ubiquitous, it has to touch an area that is very uh, that that is popular or in high demand. And I think the whole area of security, JB, and such is going to drive adoption. It's going to be an area where we can help. The compressibility certainly has driven some, like with ourselves and you. I think I think security, ransomware security. Can't tell you exactly what area yet. We're still in early days. I think that's going to have a lot of potential, and I can't tell you exactly what year or when, but I think that's an area where we're going to see a lot of demand and effective utilization. What do you think?
I think April 15th, 2024.
Tax day, huh?
Hey,
You're
it's inevitable, right? Um,
you're employing technology to reduce our taxes, then it will be ubiquitous, I'm
Within,
sure.
yes, exactly. No, I kidding aside, it's pretty similar thinking. Um, it's going to be a while for true ubiquity of computational storage, but I think a function like the compression is something where we've kind of we've moved around that changing the software barrier to try to make it easier to consume to allow for it to get broader deployment more rapidly. And there's the vast majority of data out there is compressible at some stage in its life
Yeah.
before it's encrypted.
Oh,
And then, as you
I like
mentioned,
how you
the
put
security is a huge
yeah.
way that we might be able to take advantage as well.
I like how you put that, JB. Most of the data out there is compressible in some stage of its existence, uh, because that says, well, JPEGs and stuff really aren't. They get compressed right away, right? But most other data, database data, tends to be compressible, right? So
Yep. Yeah. And even those images, what we see is the professionals, they're capturing raw, right? And those raw data
ah,
files, those raw image files can be huge.
oh
The
boy,
JPEGs are lossy compression, right? So being able to
yeah,
do the lossless compression and store five times as many raw images can save people a lot of space as well.
excellent point.
So, all right. Well, I thank you for taking time out of your very busy schedule to meet with us and chat today. Any closing remarks?
No, I want to thank you for the opportunity. This has been fun, but it's more than that. I look forward to giving folks a chance to think beyond maybe what they're doing and use what we've said as a springboard to go. You know, what can we do with this computational storage technology? And think about it, and let's innovate together and really change the industry again.
All right. Well, thank you again, Andy, for your perspectives from your. You said 4 decades. I wasn't going to go that long in the industry. Always a pleasure to talk with you,
Thank you.
and thanks again.
My pleasure. Thank you, JB.